Hello, this is Ms. DB, and we are on the last section of Chapter 6 on properties of kites and trapezoids. These are going to be quadrilaterals, but not parallelograms. We're moving away from the parallelograms, and we're going to talk about kites and trapezoids and use those properties to solve problems. So remember that these are not parallelograms, so the things that are true about all the last 4 sections we've done are not going to be true. We have quite a bit of vocabulary today, most of it dealing with the different parts of a trapezoid. A kite, you should know this definition, it's a quadrilateral with exactly 2 pairs of congruent consecutive sides. In this picture, you'll see that AB is marked congruent to AD. They're congruent and next to each other. That's consecutive. And also the BC is congruent to DC. Now, it is not given in the definition, but it'll make your problems easier to solve if you recognize or if you know that this angle is congruent to this angle. These 2 angles opposite each other are congruent to each other. A and C are not congruent to each other. These 2 angles are not congruent. These 2 angles are congruent. And you can prove that in different ways, but it's enough right now for you to know that it'll make your problems easier if you know that that's true. A and C, however, are not congruent to each other. All right, if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, they intersect at right angles. That means that you take a kite and you can divide it into 4 little right triangles, which means that you can use the Pythagorean theorem to find missing parts of any. If you're given 2 parts of that right triangle, you can find the missing part. Also, 1 pair of opposite angles are congruent. I just went over that with you. Only these 2 angles are congruent. The other 2 angles are not congruent. In this problem, which is lengthy looking, but we're going to solve it without all of their steps. All right, we're given that it's a kite. We also know that 2 sides are 18 and they're congruent to each other, and that there's 2 other sides that are 27 and they're of course congruent to each other. We also are given, what is this? 2 dowels that measure 18, 1 dowel that measures 30, and 2 dowels that measure 27. So the 30-inch or 30 centimeters is right here from J to M. So this is 15 and this is 15. Also, she has a dowel that is 36, and this question is how much wood will she have left after cutting the last dowel? So this plus this has to be less than 36. Okay, let me call this point P. So KP plus PL has to be less than 36. So what we need to do is figure out what is this and what is this. All right, so let's figure that out. We have a right triangle, this triangle right here, that is 18 inches along here and 15 along here. And we need to know what is one leg, I'll call that A, of this right triangle. So I could go 15 squared, leg squared, plus the other leg squared is going to be equal to 18 squared. 15 squared is 225. 18 squared is, let's see, that's 64, 8, 14, 0, 8, 1. I should have this memorized, but 324, okay. That's equal to 324. And then we'll subtract 225 from both sides, and we'll get A squared equals, let's see, that would be 1. I'm losing my, what am I doing? 324 minus 225 is 99. So A is equal to the square root of 99, which is 3 times the square root of 11. I don't know if we need to know that. I guess we kind of do. And then this is 3 squared 11. We should have that as a decimal. And then the other one is going to be, let's see, this is 15 squared. Here's another right triangle with one leg is 15 and the hypotenuse is 27. So we'd go 15 squared plus B squared equals 27 squared, and we'll solve that. I'm going to go to the next page to see what these numbers are as decimals. All right, so 3 squared 11 is about, oh, they don't have the decimal version. And then the other one is 6 squared of 14. I kind of need to know what these are as decimals, so they figured that out as 32.4. Now the dowel was given as 36. That's what she had to work with. So then we would just subtract to find how much is left. All right. This is just a plain old problem instead of a word problem. We are given that measure of angle DAB, this angle is 54, and also that measure of angle CDF, this angle here is 52. Find measure of angle BCD. We want to know what is this angle. All right, here's how we're going to do that. We know that BC is congruent to CD. If you have two sides of a triangle, see this triangle here, that are congruent, we know it's an isosceles triangle. And if it's an isosceles triangle, it means that their base angles are congruent to each other, which means that angle CBF is also 52 degrees. Okay, so now we have a triangle. This is DBC, and we know that these two angles are both 52 degrees. We can find the third angle because we know that there's 180 degrees right here. So this angle right here is going to be 180 minus 52 minus 52. So that's, oops, I went too far. That's 76 degrees. So in this first question, we didn't use the 54 at all, and we're able to find that this is 76 degrees. So there might be information in the problem that you don't necessarily need, but we might need it in this one because now they want the measure of angle ABC. They want this angle. Now we just found that this was 76. We know that this is 52. We also know that angle ABC is congruent to angle CDA. So we know that that altogether, all four of those angles is equal to 360. And you know that because there are 1, 2, 3. This is the from section 6.1. You could use the formula n minus 2 times 180 to find the sum of the interior angles. And it's 4 sides, so 4 minus 2 is 2, times 180 is 360. Every quadrilateral will have a sum of 360 degrees of all their interior angles. So we've got 52 plus 76 plus angle ABC plus angle ADC is going to equal 360. So if we subtract what we know from 360, let's see, 76 plus 54 is 130. So if we subtract 130, we get 230. But these are the same. There's 2 of them and they're the same. So we could just divide that by 230, or 230 divided by 2, and we'll see that the angle is 115 degrees. Okay, here's another kite. In this one, we know that angle DAB, this one is, oh, it's the same one, 54, and this was 52, and we already found that this was 76, and we know now that this was 115? And now they want the measure of angle FDA. FDA. They want this angle. So to find that, let's see, we know that angle CDA, where's CDA? CDA is congruent to ABC. Yep, got that. Oh, so if this is 115 down here, all we have to do is subtract 52, and then we'll be able to find the missing angle, which would be 63. All right, now let's move on to trapezoids. There's lots of parts of the trapezoid that you need to know. A trapezoid has exactly one pair of parallel sides. Only one pair, not two. Two would make it a parallelogram. A trapezoid only has one pair of parallel sides. Each of the parallel sides is called a base. So we got a base and a base. The non-parallel sides are called legs. So we got a leg and we got a leg. Base angles of a trapezoid are two consecutive angles whose common side is a base. So these are base angles down here. These are also base angles up here. If the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. Now, with just a regular trapezoid, there's really not much for theorems that can go along with it. There's really no way to find the lengths of legs or bases or the missing angles. All four angles could be different, the legs could be different, the bases can be different. There's really nothing to do with a trapezoid if you don't know that it's isosceles. Now, in an isosceles trapezoid, then we have a lot of theorems. This is a base and this is a base, and this is a leg and this is a leg. The legs are congruent. That means that more things will also be true. And the things that will be true is that each pair of base angles will be congruent. So this angle is congruent to this angle is congruent to this angle. Also, if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So it means that a trapezoid with pair of base angles, then you also have that it's isosceles. And a trapezoid is isosceles if and only if its diagonals are congruent. So this one works both ways. If you know that the diagonals are congruent, then you know that it's an isosceles. Also, if you know that it's an isosceles trapezoid, then the base angles are equal. I mean that the diagonals are equal. So it goes both ways, that one. All right, so in this one, it says find the measure of angle A. We know it's isosceles because these two sides are marked congruent to each other. We know it's a trapezoid because one pair of opposite sides are parallel. We know this is 100. We could also know that this is 100 because the base angles are equal to each other. How are we going to find measure of angle A? The same side interior angles theorem. Remember, this side is parallel to this side. These two are interior same side angles, so it means that together they're supplementary. Angle B plus angle C is supplementary, so it's equal to 180. So 100 plus 80, so this is an 80-degree angle, and that would mean that this is 80 degrees because they are base angles, and base angles are equal. Okay, in this one, we also have an isosceles trapezoid. How do we know that? We have parallel opposite sides, and we have that the legs are congruent. KB is 21.9, and MF is 32.7. They want us to find FB. They want us to find this piece. Well, in an isosceles trapezoid, the diagonals are equal to each other. So 21.9 plus whatever, x, is equal to 32.7. And that little piece is going to be the same on both of them. All right, so we know that 21.9 plus that missing part is equal to 32.7. So we find the missing part, and that's 10.8. They're doing a lot of work. Why are they doing so much work? To say that it's 10.8. That's crazy. Okay, I'm going to go back here. You absolutely do not have to go through 1,000 steps to say that it's the same. This diagonal is the same as this diagonal. Okay? So this they found was, what was it, 10 point something? 10.8, okay. 10.8. We know that if 21.9 plus 10.8 equals 32.7, this has to be the same thing. Now, there isn't a property that says that they are, so what they did is they went through and said that this triangle was congruent to this triangle. And those are vertical angles, and these two sides are congruent, and then they found some other, I don't know, they used alternate interior angles or something. It doesn't matter. these two triangles are congruent, so these two parts are the same. So if this is 10.8, this is 10.8. So in the future, just use that. It's way more work than they had to do. Okay, find the value of A so that PQRS is isosceles. In order for it to be isosceles, base angles have to be equal. That means that these two would have to be equal to each other, so we just set these two expressions equal to each other. Now it's got a square in there, but what's going to happen is because you have no A term, you're not going to have to do anything too complicated here, like factoring. You'll just be able to, if we subtract A squared from both sides and add 54 to both sides, we'll get A squared equals 81, and then you just take the square root to solve that. And that happens to be a nice number of A equals 9. Now, A equals -9 also actually works in this case, because if you put -9 in here and squared it, you'd get 81. So there's two answers for this one, which we often throw away the negative one, but in this case, the negative one will work too. So you'd have two answers. All right, here's an example where they have given AD, that's a diagonal, is 12x minus 11. That's this diagonal. And BC, they're giving us the other diagonal, is 9x minus 2. Now in an isosceles trapezoid, the diagonals are equal to each other. So we want to show that it's going to be isosceles at a certain point. So you'll set those two expressions equal to each other. Solve for x. You get x equals 3, and that's the value of x at which this would be isosceles. So if x is 3, you have an isosceles trapezoid. Okay, one more little theorem here, kind of stuck at the end, midsegment. The midsegment of a trapezoid is when you take the midpoint of the two legs, both midpoints, and then connect them. That's a midsegment. So it's similar to the midsegment of a triangle because you connect the midpoints of two sides, in this case two legs. There's a theorem that says that that midsegment is going to be parallel to the two bases of your trapezoid, and also that it'll be half the sum of the lengths of the base. So if I knew this was 10 and this was, I don't know, 6, I would take 10 plus 6 and divide it by 2 to find out that xy would be equal to 8. So it's you add the two bases together, divide by 2, that gives you the midsegment length, which is which is nice for solving problems. All I have to do is add the two bases together and divide by 2. So 10.75. It also, you may have a problem, like a little bit more challenging one, if they give you that this is something and they want you to find another base. You could do that by saying that the midsegment of 10 is equal to half of b plus 8. So if you're asked to find the length of one of the bases, you would start by multiplying both sides by 2 to get rid of the 1/2. So 20 is equal to b plus 8. And then you would find out what the other base was. All right, so that's it for today's lesson. Please ask me if you have any questions. Thank you very much.